Hello students, welcome back to the fifth self-assessment test that is on tillage and soil erosion and conservation. So many things we'll cover. We are going to cover 100 MCQs which are important, which are being asked in different competitive exam. So let's start with our first question, that is, who is regarded as the father of tillage? Everyone must know this. This is Jethro Tull. Which book he has written? That is Horse Hoeing His Husbandry. So our next question is, the book written by Jethro Tull is Horse Hoeing Husbandry. Okay, so Jethro Tull is considered as the father of tillage. So initially he was the first one who used the term weed as well. So he has written the book Horse Hoeing Husbandry. Next question, aggregate size or diameter of aggregate that is desirable for dryland agriculture. Aggregate size, that is diameter of aggregate that is desirable for dryland agriculture, that is 1 to 2 millimeter. 1 to 2 millimeter. So smaller aggregates that is required for suitable for dryland agriculture, and larger aggregate like more than 5 mm that is required for, or that is suitable for irrigated agriculture. Next question, the property of soil by which the soil become crumbier when dry. The property of soil by which the soil become crumbier when it is dry, that is called friability. Friability is that property of the soil. So basically when it is not friable, then it will form lumps. Okay, it will form, that is basically you can find in clay soil that after tillage, if it is dried and it is very hard. Okay, but if the soil is friable enough, then it will be in powder form or crumbier form. Next question, the optimum proportion of capillary and non-capillary pores of soil having good tilth. So when we can call it as a good tilth? After tillage, the final condition is called tilth. So tilth is basically nothing but the physical condition of the soil after the tillage. So when the capillary and non-capillary pores are basically micropores and non-capillary pores are macropore. Capillary pore, the diameter is less than 0.06 mm, and non-capillary pore, the diameter is more than 0.06 mm. So if you'll see clay soil, there is more capillary pore, and in sandy soil there is more non-capillary pore. And when their proportion is 1:1, that means they are in equal number, then that is called the optimum condition of the soil. Okay, or optimum condition of the tilth. Then the proportion of rhizosphere on an average occupied by roots of crop is. So how much volume of the rhizosphere that is taken up by root, that is 1/10 of the soil or rhizosphere that is taken up by the root system. Next question, who is known as the father of zero tillage? Who is known as the father of zero tillage? Remember GB triplet. GB triplet is considered as the father of zero tillage. Next question, the book Plowman's Folly was written by. The book Plowman's Folly, that was written by E. Faulkner. The book Plowman's Folly, that is written by E. Faulkner. Next question, according to Jethro Tull, why one should plow or till the field properly? See, Jethro Tull gave a concept that he was the first person to propose कि you should till the soil, or you must plow the soil. So what was his concept? That plant actually plant do not take nutrient and water and all. Plant take finer soil particles. So when you plow the soil, the particles become finer and plant can easily take up them for its nutrition. But that is, the concept is wrong, but he was a pioneer of tillage. So according to him, plant can absorb finer particles. Okay, plant can absorb finer soil particles. So if you are not tilling, then plant cannot absorb those particles. So basically that was the concept given by Jethro Tull. Next question, what makes the soil compact and need for proper tillage before sowing of the next crop? What makes the soil compact and it is needed for proper tillage before sowing of the next crop? So raindrop, yes, of course, raindrop, when rain is falling, it is having higher kinetic energy, which de-silt or which disperse the soil particle, and that become the soil more compact. That's why the live mulch concept is there, mulching concept is there. So vegetation, keep the soil with vegetation cover, that is also there. So rainfall is definitely contributing to the soil compaction. Then farm machinery load is also contributing to soil compaction. Then movement of labor and animal, they are having certain weight, so they will also make the soil compact. So all of them contribute to the or attribute to the soil compaction. Next question, which is not true with respect to conventional tillage operation? Which is not true with respect to conventional tillage operation? Increase oxidation of soil organic carbon. Of course, in conventional tillage, what we are doing, basically we are doing both primary tillage and secondary tillage. So when you till the soil more, there is more microbial activity, the soil organic matter that is exposed to solar radiation as well. So there will be more oxidation of soil organic carbon. Next, decrease in soil thermal conductivity. Yes, because when you are tilling the soil, you are increasing the porosity, you are breaking the clods, you are increasing the porosity. So when there is more porous soil, then the thermal conductivity decreases. Then increase prevalence of perennial weed flora. This is wrong actually. So when we are going for conservation tillage, that means zero tillage and minimum tillage, then there is prevalence of perennial weed flora. Okay, so this one will be correct. That is not true with respect to conventional tillage. Next, increase root penetration and proliferation. Yes, for this region we are doing basically conventional tillage because it can move deeper and deeper. So the right answer will be increased prevalence of perennial weed in case of basically this perennial weed population increases when you are going for zero tillage. Next question, which of the following soil physical property remains constant after tillage? Which of the following soil physical property remains constant after tillage? See, actually particle density, that remains constant because ball density, the formula is mass of soil divided by total volume of soil. So when this total volume consists of volume of soil solid and volume of soil porosity. So when you are tilling the soil, the porosity increases, so it changes. But particle density, that is mass of soil by volume of soil solid. So volume of soil solid will not increase after repeated tillage. Porosity, it will increase, infiltration rate, it will increase, then bulk density, it will decrease. So the right answer will be particle density. Next, destruction of soil structure on tillage largely depends on. Destruction of soil structure on tillage largely depends on first, frequency of tillage. It is not that much frequency of tillage. If you are mostly like frequently tilling the soil, yes, it will destroy, but that is not that much important. Type of tillage you are following, that is also not that much important. Implement use tillage, that is also not that much important. But soil moisture content, if you are not tilling the soil with optimum soil moisture, then there is more chance of soil structural deterioration. So when basically the soil is more drier, then there will be powder formation of the soil if you are tilling continuously. If it is more wet, then there is severe deterioration of soil particles because that is suboptimal moisture condition. So mostly at field capacity, near about field capacity, the soil is at optimum moisture condition and you must till at that particular point. Next question, which of the following soil property decreases after tillage? Which of the following soil property decreases after tillage? See, water holding capacity, it will increase because more porosity will be there. Infiltration rate, it will increase. Hydraulic conductivity, it will increase, but soil thermal conductivity, that will decrease. Okay, so when you are tilling the soil, then there will be more porosity. More porosity means decrease in thermal conductivity. Next question, which tillage method is not fall under preparatory tillage? Which tillage method is not fall under preparatory tillage? So during preparatory tillage, that means before planting the tillage is done. So primary tillage, yes, for rough land preparation, that is done. So initial tillage is known as primary tillage, that is by plows. Then secondary tillage like harrowing and all, that is to break the large clods that is formed in primary tillage. The layout of seed bed before sowing or before sowing in main plot, you have to lay out the seed bed. That is also preparatory tillage. But earthing up, when it is done, after crop establishment. So earthing up is the correct answer. Earthing up will be the correct answer for this question. So this is the after tillage, that means or inter tillage you can say, in between crop period, that is being done. Next question, the range of optimum soil moisture for effective plowing. The range of optimum soil moisture for effective plowing, that is 25 to 50% of depletion of soil available soil moisture. 25 to 50% of depletion of available soil moisture, that is optimum soil moisture for effective plowing. Okay. Next question, which of the following soil can be plowed in a wider range of soil moisture? Which of the following soil can be plowed in a wider range of soil moisture? That is sandy soil. Okay. So in clay soil, heavy soil, clay soil is basically the heavy soil, and in loamy soil the range is very narrow, but in sandy soil the range is wider, because sandy soil it is almost consist of larger soil particle and more macropores. So they will not stick together, and there will be no more stress on the plowing implement or other implements you are using for tillage. So sandy soils, and they are not sticky, as I said. So you can plow the sandy soil in a wider range of soil moisture. Next question, depth of plowing depends on depth of plowing. So when you are tilling the soil or plowing the soil, at what depth you should plow the soil? So that depends on mostly the effective root zone depth. That depends on effective root zone depth. What is effective root zone depth? That means when you are growing a plant, that means when you are planting a seed, or up to what depth from which maximum soil, water or nutrient it is taking up, the plant is taking up, that is effective root zone depth. So up to effective root zone depth you should plow the soil. Next question, which of the following is a multi-purpose plowing implement and most widely used by farmer? Which of the following is a multi-purpose plowing implement and which is most widely used by farmer? That is country plow. Country plow, or it can say desi plow, that is a wooden plow. Country plow or desi plow, that is most widely used by farmer. Next question, according to plowing depth categorized by CREDA, the depth beyond which it is called deep plowing. According to plowing depth classified by CREDA, the plowing depth beyond which it is classified as deep plowing. Okay, that is 25 to 30 centimeter. Okay, so shallow plowing 5 to 6 centimeter, moderate plowing or medium depth plowing 15 to 20 centimeter, and deep plowing 25 to 30 centimeter. So it was classified by CREDA. CREDA means Central Research Institute in Dryland Agriculture, for dryland agriculture, that is situated in Hyderabad. Okay, and it was formed in 1985. So remember this one. Next question, subsoil hard pan is formed due to repeated plowing at same depth. So when you are repeatedly plowing at a same depth, there will be subsoil hard pan, because you are basically you are using some implement for plowing at the same depth. So that implement actually that is compressing the soil, and in subsoil what happens, there is more moisture. So that is, in moist condition the compressibility is more, and dry soil you cannot compress that much, but moist soil that you can compress more, and you are repeatedly plowing at the same depth. So the upper soil which you are plowing, that will be loosened, but below that there will be formation of hard pan, because you are not doing. That's why it is recommended that at least 2 to 3 years interval you must go for a deep plowing. Next question, which of the following is not a secondary tillage implement? Which of the following implement is not a secondary tillage implement? See, plank, it is a secondary tillage implement. Cultivator, it is a secondary tillage implement. Harrow, it is a secondary tillage implement. So no implement from this option is a secondary tillage implement. It's not a secondary tillage implement. All are secondary tillage implement. Okay. Next question, in which planting method inter-row space is not cultivated? In which planting method inter-row space is not cultivated? Flatbed planting, yes, it is cultivated because some weeds will come up, then earthing up may done, then reason for a method it is already. So if you are not into cultivating, then how you will make the reason for. In set line planting, actually set line planting, that is followed in cotton and groundnut, in mainly in Gujarat this method of planting is done. And what happens here, this is a method of zero tillage actually. So here what happens, so the lines are set, and in the next year, suppose this year you just plowed this line and you just sow the seed there. Again next year you just plow the same line and you just sow the seed. So that is set line. Line is already set and you are plowing that line only, you are tilling that line only, and you are sowing the seed. Inter row space will not be disturbed. Next, the concept of minimum and zero tillage started in USA due to the concept of minimum and zero tillage started in USA mainly due to increase in oil price. Okay, so what happened in 1970s actually, so there was heavy use of these implements, tillage implements, and more intense tillage was being done practiced in USA. And there is dust bowl formation, and same time what happens, the oil price was increased, like it was increased so much that people started using conservation agriculture or started using zero tillage practice and minimum tillage practice, because they felt the oil price is rising, and we are already in the situation of dust bowl, and the soil structure is deteriorating. So they switched it into zero tillage. Which is not true with respect to minimum tillage? Which of the following is not true with respect to minimum tillage? Less soil compaction, higher immobilization. While it will, the soil compaction will be less in zero tillage, because we are not using many implements, and repeated implements not used. Then there is root biomass is already adhering to the soil and subsoil. Then the soil is already under cover of the weeds and crops, so more rainfall impact cannot be that much, so there will be less soil compaction. See, reduced use of herbicide, this is incorrect, because in minimum tillage or zero tillage condition you are not using tillage implement. So how you will remove the weeds, how you will maintain the weed free situation? You have to use more non persistent herbicide. Okay, so when you are using herbicides, then only you can maintain it weed free. Okay, you can make it weed free. So mostly paraquat, glyphosate, they are being used in minimum tillage or zero tillage condition. So after their introduction, paraquat and diquat and as well as glyphosate, the zero tillage came into existence. Higher immobilization of nutrient, because there are more organic matters having more CN ratio, so organic matter immobilization or nutrient immobilization will be more. Higher incidence of perennial weeds, yes, of course, because you are not rotating you are not removing the weeds mostly, so more number of perennial weeds that will emerge at that condition. Next, which of the following is not a minimum tillage practice? Which of the following is not a minimum tillage practice? All these three, row zone tillage, plow plant tillage, and wheel track planting, they are minimum tillage practice, but till planting is a zero tillage operation. Till planting is a zero tillage operation. So this will be the correct answer. Next question. The heavy incidence of weed flora in zero tillage due to minimal use of tillage implement is controlled by. The heavy incidence of weed flora in zero tillage we just discussed after the introduction of paraquat, glyphosate, all these herbicides. So there was increase in zero tillage and minimum tillage. So the right answer will be herbicide. Next question. The seed requirement in zero and minimum tillage planting with respect to conventional tillage will be more or less, or what? That will be more, because there will be more incidence of pest and disease incidence. Then there will be like we are not properly tilling the soil, we are not preparing the seed bed properly, so there will be less germination. So at least 20 to 25% more seed rate you have to place. Next question. The word tillage originated from which word? tillage basically originated from Anglo-Saxon word, that is Tillian, Tillian or Teolian, Tillian or Teolian. Okay, so this was originated in from Anglo-Saxon word. Next question: which of the following tillage implement is not useful for intertillage? Which of the following tillage implement is not useful for intertillage? Spade, hoe, plank, none. So basically plank is used for leveling and yes, mostly for leveling the soil after primary and secondary tillage. So in intertillage implements, spade can be used for intertillage like for earthing up and all. Then hoe can be used for intertillage like for weeding. So the correct answer will be plank. Next, which of the following special tillage operation is done for breaking of hard pan? Which of the following special tillage implement that is done for breaking of hard pan? That is chiseling or chisel plow. Okay, so earthing up is basically when you are gathering the soil or on the root zone so that it will not topple over, or the root zone, it will support the base and it will not lose. Okay, in case of like maize, then in case of sugarcane you can go for earthing up. Then puddling is basically done in rice, that is also a special tillage operation. So basically in suboptimal moisture condition you have to till the soil and in standing water, so that there will be structural breakdown and there will be formation of the hard pan, and that percolated water that is checked. Contouring or contour tillage, that is practiced in hilly area where there is more slope, so that is breakdown into small slopey area, and there will be a plain surface and you have to cultivate in those contour lines. Okay, so basically here for hard pan breakdown, chiseling is done. Next, the special tillage practice which is done after sowing and before emergence to remove weeds from the field. After sowing and before emergence you have to do that practice and to remove the weeds. That is called blind tillage. Okay, that is called blind tillage. Contour tillage we just discussed. Clean tillage means the primary tillage and secondary tillage, basically to clean the field. Then subsoiling is basically to for hard pan, removal of hard pan, then or deep plowing. Blind tillage is done in case of late germinating crop seeds. So after sowing you have to blind till, or you have to till the soil to remove the weeds. That is blind tillage. Wet tillage is a special purpose tillage that is also called puddling. So basically in puddling what we do, we have just discussed, that is followed in rice or paddy cultivation. Next question: the optimum moisture content for tillage. What is the optimum moisture content for tillage? That is somewhere around 50 to 60% of field capacity. So we just discussed 25 to 30% of available soil moisture, depletion of available soil moisture, and somewhere 60% of field capacity. So all these things you just remember these values. So in some question you can find this DSM approach, and in some cases you can find field capacity. Next question: which of the following is not a no-till farming method? Which of the following is not a no-till farming method? That is wheel track seeding. Okay, wheel track seeding. So basically what happens when there is like sowing and that implement is the seeding implement is attached to the machinery. So when the machine runs, the wheel line that is suppressed by weed flora, and the weeds are suppressed by the wheels, and in that wheeling line, that means where the wheel goes, there the sowing itself done. So that is called wheel track seeding, and that is not a no-till farming method. Okay, surface seeding, that is a no-till farming method. Direct seeding, that is not no-till farming. Short seeding, that is also no-till farming method. So wheel track seeding means, so basically the tillage is done basically by the wheels, so that you cannot say no-till farming method. Highest adoption of no-till farming in the world is in that is in South America. mostly that Brazil, then Argentina, they followed no-till farming method. Next, gardening tool that aerates the soil without overturning it. Gardening tool that aerates the soil without overturning it, that is broad fork. Okay, without overturning that implement actually aerate the soil. Next question, tillage that leaves 15 to 30% crop residue cover on the soil is called. Tillage that leaves 15 to 30% crop residue, that is called reduced tillage. Okay, so conservation tillage, when we say when it is more than 30% crop residue. Conservation tillage when more than 30% crop residue. Intensive tillage when less than 15%, or conventional tillage that is less than 15% crop residue, and reduced tillage 15 to 30% crop residue you have left. On an average, the amount of crop residue above which to be present on the soil surface to be regarded as conventional tillage. On an average, above which to be present in the soil surface to be regarded as conventional tillage. It is not actually conventional tillage, it is conservation tillage. This is conservation tillage. Okay, because in conventional tillage you are not remaining any residue, crop residue. Okay, so it is more than 1100 kg per hectare. It is more than 1100 kg or 1.1 ton per hectare. Next question, which soil is called self-till soil? That is vertisoil or clay soil. Mostly they are called self-till soil. So basically what happens after tilling in vertisoil, due to their expansion and due to their the plasticity of the soil, they actually come back again to the same position after some time. So they are called self-till soil. That is vertisoil is called self-till soil. Next question, which of the following tillage is done for creating impervious soil layer to restrict deep percolation loss of water? Which of the following tillage is done for creating impervious soil layer to restrict deep percolation loss of water? That is wet tillage. Okay, so basically we have discussed what wet tillage is, that is nothing but the puddling. Next question, biotillage involves tillage with the help of biotillage involves the tillage with the help of plants. Basically what happens, so when plant root enters the soil, so they form biopores, right? And they basically, these roots have basically so much energy that they can self till the soil, they can self destroy the soil structure, or they can find their own way to move inside the soil. That is called biotillage. Next question, which of the following tillage reduce the emergence of weed flora and reduce the use of herbicide thereby? Which of the following tillage reduce the emergence of weed flora and reduce the use of herbicide thereby? So wet tillage, it can also reduce the weed flora or emergence of weed seed. Night tillage also, because in night tillage, when you are doing night tillage, so basically the weed seeds are exposed to night, so negative photoplastic seed they will not photoplastic seed they will not germinate in night. Then summer tillage also, it expose the weed seeds to solar radiation, high intense solar radiation, so that will also destroy the weed seeds. So all of this practice, they will reduce the emergence of weed flora and reduce the use of herbicide. Which of the following is a foundation that dedicated to the assessment of tillage related erosion in Europe? Tillage related erosion, so that is Terron. Okay, see, tillage related erosion. So this is one foundation that was dedicatedly established for assessment of tillage related erosions in Europe. Because see, tillage, intensive tillage, that is always destroying the soil physical properties, and that is always having negative impact on soil. So, and that is that scientists have already seen this in several countries and several continents. So they are trying to implement this zero tillage and conservation tillage practices. Next, the percentage saving of water and nutrient in zero till planting over conventional tillage. So this type of question also coming in NET exam and SRF exams. The percentage of saving of water and nutrient in zero till planting over conventional till planting, that is 20 to 30%. Next, reported water saving 35 to 45% following lesser land leveling is due to higher which type of efficiency. So there are different efficiency like conveyance efficiency, application efficiency, storage efficiency, distribution efficiency, field efficiency as well. So in case of lesser land leveling, which type of efficiency is more? That is application efficiency. So what is conveyance efficiency? Conveyance efficiency means this is, let's say this is the pond or any river or whatever, this is your field. So how much water is released from this field and how much water is entering, how much water is entering to this field and how much water is released, that is called conveyance efficiency, and losses during this, that is called conveyance losses. Then inside the plot, how much water is reaching to the root zone and how much water is entering, that is application efficiency. So that is actually increasing here in case of lesser land leveling. So basically you are micro leveling the field and this application efficiency is increasing in lesser land leveling. Next, friability index represents the moisture difference between, friability index represents the moisture difference between shrinkage limit and plastic limit. Okay, shrinkage limit and plastic limit. So basically what is shrinkage limit? Shrinkage limit means, so when you are trying to make the soil a mud ball and it is no more adhering to the moisture below which, that is no more adhering to each other, like the soil particles no more adhering to each other and you cannot make form a ball and that is breaking down continuously, then that is called shrinkage limit. Then plastic limits means when you can press that and you can make that ball, that is plastic limit. Then another one is liquid limit. Liquid limit means above which moisture level that will easily flow down. Okay, above which moisture level that will easily flow down. Okay, so you cannot that is basically liquefied. So that this shrinkage limit and plastic limit, in between there is that is called friability index and that is the optimum moisture condition for tillage. Optimum water content for tillage, the soil moisture content at which tillage produces, optimum water content for tillage, that is called OPT, is the soil moisture content at which tillage produces largest number of micro aggregate, largest number of macro aggregate, tilth can hold more water, soil become more friable. So the right answer is largest number of micro aggregate. So this is almost desirable, largest number of micro aggregate formation. For most of the soil, optimum water content for tillage is, for most of the soil, optimum water content for tillage, that is OPT, that is 0.9 PL. Okay, that is plastic limit. This PL means plastic limit. Then inverted T-type furrow opener is used in, zero till drill. Okay, basically zero till drill like happy seeder, turbo seeder, there this inverted T-type furrow opener is used. Okay, so this was about 50 MCQs on tillage, and if you know some brief idea about tillage or other self-assessment test, you can click here. Again, this carbon and nitrogen dynamics in conservation agriculture, you can also click here and watch this lecture. So this is about tillage. Next we'll discuss soil